Hello everyone, my name is Busisire and I am from Sci Enza Science Center from the University of Pretoria. In today's video, we're going to talk about energy in chain in musical instruments. First, let's talk about energy. What is energy? Well, energy is the ability to do work. Energy cannot be created nor destroyed. However, it can change from one form to another. We need energy to do anything. This could be as simple as opening your eyes or breathing, to washing dishes or even doing your homework. Now, since we're talking about energy in chain in musical instruments, we cannot talk about musical instruments without talking about sound. What is sound? Well, sound is simply vibrations. These vibrations can move through a medium. This medium can be in a form of gas, solid, or liquid. Now, I have a tuning fork. Now, this tuning fork is going to help us demonstrate how energy can be transferred when making sound. Now, this tuning fork at rest has potential energy. Potential energy is the energy stored. When I hit this tuning fork, it makes sound because it's vibrating, and when it vibrates, it has kinetic energy. Kinetic energy is the energy of movement. Now that we know how sound is made, let's look at the different instruments that we have, because we have different kinds of instruments, including our voice. You can name it. It's a lot of instruments. Drums, piano, guitar. There's a whole lot of them. One thing that we know is that these instruments are made differently. They differ in size, they differ in shapes, and how we create vibrations differ from one instrument to the next. We're going to start with a drum. With a drum, you can simply beat it and it makes a sound. This layer makes vibrations that we can all hear. Now, moving on to the next instrument, we have this simple pipe over here that has rings stacked on top of one another instead of them spiraling down. How can we create sound using this tube? Very simple. We just swing it around. Did you hear that? Cool, right? Yes. Now, just simply swinging around the tube makes the sound. So this is because the air flows inside the tube, and inside the ridges, the air collects and hits one another. It compresses and moves on to the next ridges as I swing it, and that's how vibrations are created inside this tube. Now, another instrument is a guitar, a beautiful guitar. Now, how we produce sound is simply strumming the strings or just plucking one. So as I pluck a string, it is vibrating and causing a sound. As you can see, we produce these sounds differently in different instruments. How can we hear all of these sounds? Well, let's have our humble Slinky to do the demonstration. Now, we are going to use a simple Slinky to demonstrate how particles can transfer the energy or vibrations from one place to the next. Now, let's assume this hand is an instrument and this hand is your ears. In between, the slinky represents the air particles around us and around the instrument. As I make the vibrations with the instrument, these vibrations move amongst the air particles, one from the next, transferring the kinetic energy until it reaches your ears. One more time. Yes, so that's how the particles hand over vibrations from one to the next until they reach your ear. But when the sound gets to your ear, there's more that goes into it. I have an ear model that's going to help us. So the ear consists of 3 parts. We have the outer ear, the middle ear, and the inner ear. The outer ear consists of the pinna, which is what you can touch and see. Then it has an ear canal, then the eardrum. In the middle ear, we have the 3 tiniest bones in our body, called the ossicles. And in the inner ear, we have a snail-like shape that connects to the nerve that sends all the information to the brain. Now, the outer part collects all the sounds that we can hear. It collects it and it channels it into the ear canal. Then it hits onto the eardrum. The eardrum then transfers those sounds or vibrations onto the ossicles. From the ossicles to the inner ear, that then sends those vibrations to the brain. Now the brain then interprets what kind of sounds you are hearing. Remember, it can collect all the sounds that it can possibly collect. The brain then interprets the sound that the outer ear has collected. This could differ from chirping birds, traveling cars, baby crying, all sorts of sound. And also how high the sound is, how loud it is, or how soft the sound is. Now, speaking of different sounds, there are also sounds that we find undesirable. These sounds are noise pollution. This is the sound we do not like hearing. It's not pleasant to our ears at all. This could be an ambulance siren, it could be construction sound. Others feel that it could even be a vuvuzela. Watch out. No, I'm not gonna do that. All right, so these are the different sounds that you can hear. Now, let's recap on what we learned today. We know that energy is the ability to do work, and we need energy for absolutely anything. And sound, well, sound is vibrations, and it needs a medium for us to hear it. These mediums can be solid, liquid, or gas form. And our ear has 3 parts to it. It has the outer ear that collects the sound, the middle ear that consists of the 3 tiniest bones in our bodies, the inner ear that receives all the information and transfers it to our brain to interpret the sound. Also remember, we make different sounds with different instruments. Well, I hope you enjoyed this video. And remember, we are from Sci Enza Science Center at the University of Pretoria. Bye!